Hi everyone, so today I'm going to show you our cold formed member analysis tool that is based off of CUFSM. You might be familiar with it, the constrained and unconstrained finite strip method tool that is quite popular for thin walled section designs. So I'll just log into the app here. You can get it at coldform.app or coldform.vercel.app. Both of those would relay to the same tool that you see here on the screen. So it uses the same principle, it's just a little bit smarter. It can do a bunch of cool stuff. So to use it, you'll need to log in. So if you're not already logged in like I am, there'll be a login button here at the top. All you need to do to register is enter your name, surname, company name, country, set up a password, and it'll send an email verification code which you put in there, and then you'll be able to access it for free. So it costs no money and it's free to use. You start off with the section builder. So when you click on section builder, you can choose from a list of templates for typical sections. We'll just stick with the cold form lip channel, but you'll see there's one for cold form lip zeds, heavy duty studs, sigma type sections, deck sections, and a bunch of other ones. So we'll just stick with the default. I'm not going to re-enter all of the values, but of course you can. The preview is dynamic, so that'll update as you enter the values there. When you're ready, you click on use template. That'll add it here to your sections. I've already had one, so I'll just remove that one again. And it's as simple as that. So once you add it to your project, it'll automatically calculate the section properties. You don't have to click it again, but if you did want to, you can click on the section properties calculator and that'll compute that for you. You can manually enter information here in tables, things such as material properties, node definition, element definition, springs, and constants, but it's not necessary. These tables are driven automatically by the section builder, the analysis input, and some of the other information we enter in here. From analysis, we can choose from elastic buckling, CFSM, fcFSM, vibration, plastic PMM, and then the CUTWP or warping calculations, which is not really necessary since our section properties already compute that. We'll just stick with elastic buckling because I want to show you the results and how they compare with the existing MATLAB version of CUFSM. The solution, you can choose between signature curve or general boundary condition. We'll stick with signature curve, and then of course you can specify your support conditions. I'm going to keep it pinned on both ends. We'll use a meter length element here just for this example, and then we can choose whether we want to use the reference applied loads, where we can specify axial force, moments, and by moments, shear forces, and so on. And then we'll click on submit to stress section to compute that. Alternatively, we could also go to the first yield calculator, and you can click on any of these buttons to start generating information and to place the matching reference load input value. So let's just say we've got a reference load here of 5 kilonewtons actual load, and we'll click on submit stress to section, and you'll notice that'll draw out the resulting stress diagram here in the viewer. So that's the 2D viewer. There's a 3D view in the back end, but we don't need that yet. We'll just focus on the 2D for now. And you can of course add additional values as you need. For now, we'll just stick with that. It will automatically create a half-length sweep table here for you. If you change the length values here, you can just click on auto sweep, and that'll kind of just divide it up into those half wavelengths values for you automatically. So everything is pretty much set up. From here we can just go and say run analysis. So, and you saw there at the bottom it said 20 eigenvalues. So you can set the number of eigenvalues or modes that you want to compute. At the moment minus 20. So it runs through all of those stations, and you can see it's a total of 660 computations, but it does it reasonably quick directly in the browser. Once it's finished, it'll default to the results view here. So we can see there we've got our signature curve. It kind of caps those top values because otherwise you see a flat curve looking like that. So this slider here, this Ymax slider, just allows us to kind of scale that into the view and clip whatever is outside of that exterior boundary. Now, since we've got this viewer open, you'll notice as I click on any of these nodes, or positions rather, it'll jump to the appropriate half wavelength station in the 2D view. We've also got the 3D view here in the background. Of course, we are seeing mode 1, but we can see that's what that mode shape looks like, and we can switch to mode 2, mode 3, mode 4, and so on and so on. And you can see that the half-life length or signature curve here will update accordingly. At the top, we've also got a play button, so you can actually animate or simulate what that mode shape looks like. And if I hit pause and reset, that'll just set it back. So let's jump back to mode 1. And let's just look at the signature curve. So when I click on the dock button, it just means we can have a larger full screen view of the signature curve. And as I move my cursor over any of these data points, you'll notice this label at the bottom would update with the relative load factor values computed for that particular mode. And of course, from here, I can change the mode as well if I wanted to drop or jump to any other modes, and then view the nodal result outputs. If I click on dock, it just places that back here in my results view. Now we can also generate reports. So if I click on the report contents, there's a bunch of options. I'll leave it as it is by default, and I'll click on the design pad button. And all this does is it creates a really nicely formatted output report. So from here we can see we've got a whole bunch of table data, and if I scroll past all of the results, which I can switch off in the report contents, this is live, so if I uncheck any of these options, it'll take it out of the report, and maybe not the top one, but anyway, you can choose what you want to see. You can see the report actually does grow and add things to it as we add to it. Maybe I should improve the options there a little bit, but this gives you a good idea of what it does. Anyway, so we can see for all those mode shapes, we've got the signature curves plotted out here. Then it gives us a view of that stress diagram drawn on top of it from the converted stress elements. And we start with 3D outputs and cross-sectional outputs for all of those modes. Of course, you can send this straight to Microsoft Word as well, so you can export the DOCX file from it and then open that and edit that further in Microsoft Word. But it does a pretty good job of generating a nice looking report. So that's where it is currently. If we look at the accuracy of results, let's jump into that a little bit. So what I've gone ahead and done is I've started building a similar model here in CUFSM version 5.66. So I've used the same properties as the default sample in our tool, CFMA. And if we submit this to input, we can see there's our section. Let's go to the applied stress generator in this tool, and we'll add there also P is 5, submit the stress to input. We'll go back here again, we'll go to the lengths and boundary conditions. That all should be fine, so we should be able to just run the analysis on the elastic buckling. It's already 20 modes here as well, so give that a second to finish. And we can see, here we go. So at length 30, we've got a load factor of 30.2673. And if we jump back to our tool, if we look at, let's go down to the plot. If we look at a length of 30, there it is. We can see we've got 30.267 compared to 30.2673. So that's pretty good. Let's jump one station ahead here, or maybe a little bit more. Let's go up to 200. Plot shape. We can see we've got a load factor of 60.9365, and if we do the same, if we jump up to 200, which should be around about here, we've got 60.937, so 60.9365, which will translate to 60.937, so pretty cool, really spot on. If we look at the different modes, so let's go to mode 2, keep it at the same length there. Oops, I clicked on the arrow, which means I'll go to mode 3. I should do that. So on mode 2 at length 200, we've got 62.5159. If we go to mode 2 here and we stay on 200, you can see we've got 60.516, 60.5159, which is 62.516, same as we've got here. And so on and so forth. I won't bore you by going through all of these, but it's pretty accurate compared to the existing CUFSM MATLAB results, except all of this runs in the browser. It's got a bit of a better user interface and super easy to use and nice report outputs that you get from here. You could also save this, so you can click on Save As and save this as a .cFMA file, which is pretty much just a JSON file, and that means in future you can open that up and you can choose the general Save As button to save with results if they are in the model. If you just want to save the geometry, you can choose Save Model Only. This means that you can generate input files quite easily from your external applications or tools or scripts or AI or whatever it is that you use, and you can then just load it straight up here into CFMA. Hope you found that useful, and let me know in the comments if there's anything you'd like me to add or if you come across any bugs or anything like that. By the way, I forgot to mention there's also metric and imperial unit support. There you go. Enjoy. Cheers.